What if the greatest mysteries of the universe aren't hiding in distant galaxies, but right in front of us, staring back, unsolved? For centuries, science has pulled back the curtain on the unknown, giving us answers to questions that once felt impossible. But there's one riddle it still cannot crack. A puzzle so elusive, so unsettling, that it forces us to confront the very limits of human understanding. We like to think science can eventually explain everything: life, death, the cosmos. Yet this particular enigma refuses to yield, no matter how advanced our technology becomes or how brilliant our minds are. It lingers like a shadow at the edge of reason, reminding us that for all we know, there is so much we don't. Tonight, we dive headfirst into the darkest mystery that science simply cannot solve. And trust me, you'll never look at the world the same way again. Chapter 1: The Unsolvable Question. Every great story begins with a question. And in science, questions are the sparks that ignite revolutions. What is fire? Led to chemistry. What are the stars? Gave us astronomy. What makes us human? Birthed entire fields of biology and psychology. But there's one question that refuses to break open, no matter how many brilliant minds attack it. It lurks at the crossroads of physics, philosophy, and human experience, yet slips away every time we think we're close. The question isn't just, what is this mystery? But rather, why can't we solve it? This is where things get unsettling. Science thrives on answers. Equations, experiments, theories. They all promise a pathway to truth. And yet, here stands a riddle that mocks the very process of understanding. Some call it the greatest puzzle of our age, while others quietly admit, maybe we were never meant to know. Think about that for a second. Humanity has split the atom, mapped the human genome, even photographed black holes at the edge of space. But this mystery, it remains untouched, like a locked door without a key. So what is it exactly that makes this enigma so impenetrable? And more importantly, why does it matter? To uncover that, we need to rewind back to moments when science itself collided with its own limits. Chapter 2: When Science Hits a Wall. Throughout history, science has felt unstoppable, an engine of progress that could eventually explain anything. But every so often, that engine stalls. A question emerges that no formula, no microscope, no telescope can seem to crack. Take the 19th century. Physicians were confident they understood disease. Yet they couldn't explain why some infections spread like wildfire while others did not. It wasn't until germ theory emerged that the wall finally crumbled. Or look at the early 20th century, when Newton's physics seemed complete, until Einstein shattered it with relativity. Each time, science appeared to hit a dead end, only to reinvent itself. But here's the difference. Those mysteries eventually yielded to human ingenuity. The puzzle we're chasing in this story hasn't. Despite decades, even centuries of effort, it remains as resistant today as it was when the first great thinkers pondered it. And that's where the tension lies. Are we simply waiting for the next Einstein moment? A paradigm shift that will suddenly make the impossible clear? Or are we staring at something fundamentally unsolvable? Because if the latter is true, then we're forced to confront a chilling possibility. That human knowledge has boundaries, and beyond those boundaries lies a permanent darkness. But before we face that shadow head-on, let's look at why the unknown unsettles us so deeply. Chapter 3: The Shadow of Ignorance. Why does the unknown scare us so much? On the surface, it's just a gap in knowledge, like not knowing the capital of a faraway country. But when that gap is cosmic, existential, or deeply personal, it feels less like a blank space and more like a shadow. Humans have always feared shadows. In ancient times, every unexplained rustle in the dark became a monster, a spirit, or an omen. The unknown wasn't just unsettling, it was dangerous. Our survival instincts taught us, what you don't understand might kill you. And though we now live in the age of satellites and smartphones, that primal fear hasn't disappeared. It's simply evolved. When science hits a mystery it can't solve, it strikes that ancient nerve. We crave certainty, but the universe keeps whispering uncertainty back at us. That whisper unsettles us because it reminds us of our fragility. That beneath all the equations and theories, we're still small creatures in a vast, indifferent cosmos. And yet, there's a strange duality here. Fear of the unknown pushes us to hide, but it also pushes us to explore, to light the torch, step into the cave, and name the monsters. It's this dual impulse, fear and curiosity, that drives every great scientific journey. And nowhere is that duality more obvious than when we look beyond our world, out into the vastness of space itself. Chapter 4: The Edge of the Universe. Stand outside on a clear night and look up. What you see isn't just a sky full of stars. It's a window into deep time. Some of that light has been traveling for billions of years just to reach your eyes. It's humbling. It's awe-inspiring. And yet, it's also incomplete. Because no matter how powerful our telescopes become, there's a limit to how far we can see. Beyond that cosmic horizon, the universe slips into silence. We call it the observable universe, but really it's just a bubble defined not by the true size of reality, but by the limits of light itself. And that raises a haunting question. What lies beyond the edge? More galaxies? Entirely new laws of physics? Or perhaps something so alien to our perception that we couldn't even recognize it if we saw it? This is where science, for all its brilliance, confronts a wall. We can model, simulate, and speculate, but the edge of the universe will always remain out of reach. It's like staring at the shoreline of an infinite ocean, knowing the water stretches on forever, but never being able to sail past the horizon. And yet, if the cosmos feels impossible to fully grasp, imagine turning the telescope inward, toward the strangest, most personal mystery of all, our own consciousness. Chapter 5: The Nature of Consciousness. Close your eyes for a moment. Think about the fact that you are thinking. That inner voice, that awareness of awareness. It's so familiar, yet so unexplainable. We call it consciousness, but naming it doesn't solve it. Science can map the brain in extraordinary detail. We know which neurons fire when you see the color red, or when you recall a childhood memory. We can even measure brainwaves during sleep and track chemical changes during emotion. But here's the problem. None of that explains experience. Why does a firing pattern of neurons feel like joy, sorrow, or wonder? Why does the brain's electrical storm translate into the rich inner movie we call reality? This is often called the hard problem of consciousness. And it's hard because it seems to sit outside the usual toolbox of science. You can dissect, record, and analyze a brain, but you can't point to a single place where you exist. Some argue consciousness might just be an illusion, a trick of biology. Others suggest it could be the most fundamental thing in the universe, more basic than matter itself. But the truth? No one knows. And if we can't fully explain the mind within our own skulls, what hope do we have of untangling something even bigger, the very fabric of time itself? Chapter 6: Time. An illusion? Time is the one thing we all live by. We measure it, chase it, waste it. Our entire lives are bound to its rhythm. But here's the unsettling twist. Science can't actually agree on what time is. To us, time feels like a river, flowing from the past, through the present, into the future. Yet physics paints a far stranger picture. Einstein showed us that time bends, stretches, and slows depending on speed and gravity. Astronauts in orbit literally age more slowly than people on Earth. Time isn't absolute. It's elastic. Then there's the even deeper puzzle. Is the flow of time real? Or is it just an illusion of human perception? Some theories suggest that past, present, and future all exist simultaneously, like pages in a book. If that's true, then the sensation of now might be nothing more than the way our brains process reality. But if time isn't what it seems, what does that mean for us? Does free will exist if the future is already written? Are we travelers moving forward, or simply characters locked into a cosmic script? And if time itself resists explanation, then so too does the greatest question tied to it. How did life first begin within its endless ticking? Chapter 7: Life's Great Puzzle. Of all the questions that haunt science, few feel as personal as this one. How did life begin? Not life as we know it today with its dazzling complexity, but that very first spark. That moment when chemistry became biology. We know Earth formed around 4.5 billion years ago, a hot, violent world of lava and storms. At some point, within a narrow window, non-living matter organized itself into something that could copy, adapt, and evolve. One day, the planet was barren rock and ocean. The next, in geological terms, it was alive. But how? Was it a primordial soup of molecules struck by lightning, creating the first simple cells? Did life hitch a ride from a comet, seeded from elsewhere in the cosmos? Or is there some unknown process, still hidden from us, that can breathe order into chaos? Despite decades of research, no one has recreated that transition in a lab. We can simulate parts of it, build amino acids, form membranes, but the leap from dead chemistry to living biology remains out of reach. And perhaps the most unsettling thought? It might not be a rare accident. Life could be written into the laws of the universe themselves. If that's true, then the cosmos might be teeming with life, far stranger than we can imagine. But if life is mysterious, death is even darker. Chapter 8: Death and Beyond. Every culture, every religion, every philosophy has wrestled with the same unshakable truth. All living things eventually die. We can describe death biologically. The heart stops, the brain shuts down, the body decays. But beyond that, science falls silent. What happens to consciousness when the lights go out? Does awareness simply vanish, the way a flame disappears when the candle burns out? Or is death a doorway, leading somewhere else? Near-death experiences add another layer of intrigue. People report floating above their bodies, moving through tunnels of light, encountering long-dead relatives. Skeptics point to oxygen deprivation and neurological tricks. Believers see evidence of something more. The frustrating truth? No experiment can follow a soul past the threshold. Death isn't just a personal mystery, it's a cosmic one. Stars die too, collapsing into black holes or scattering their atoms across galaxies. Entire civilizations vanish, their stories fading into dust. And yet, in those endings, new beginnings often emerge. Our bodies, after all, are built from the remains of long-dead stars. Still, the question lingers: is death the ultimate full stop, or merely a comma in a longer sentence? Science may never be able to answer, but to get closer, we must venture into the strangest frontier of all, where reality itself begins to bend. The world of the quantum. Chapter 9: The Quantum Veil. If reality feels stable and predictable, that's only because we're looking at it from afar. Zoom down to the quantum level, the scale of atoms and particles, and the world transforms into something utterly alien. Here, the rules of classical physics collapse. Particles behave like both waves and matter. They can exist in multiple states at once, a phenomenon known as superposition. And perhaps most unsettling, their behavior seems to change simply because they're being observed. It's as if the universe itself refuses to reveal its secrets until we're watching. Then there's entanglement, Einstein's spooky action at a distance. Two particles, separated by vast distances, somehow remain connected. Tweak one, and the other responds instantly, faster than the speed of light should allow. How? No one knows. Some physicists argue that quantum mechanics only seems strange because we don't yet have the right perspective. Others whisper that it points to something deeper, that reality isn't as solid as we believe, but more like a probability cloud, collapsing into certainty only when experienced. And if that's true, what does it say about us? Are we participants in creating reality just by observing it? If quantum mechanics bends the foundations of the microscopic world, then imagine what happens when we scale that uncertainty up to the possibility of not just one universe but many. Chapter 10: The Multiverse Question. What if this isn't the only universe? What if the reality you know, your choices, your memories, your very existence, is just one version among countless others? That's the unsettling proposition behind the multiverse. The idea isn't science fiction. It emerges naturally from some of our most advanced theories. Quantum mechanics suggests particles can exist in multiple states until observed. Some physicists take this further, proposing that all those possibilities actually happen, but in separate, branching universes. Every decision, every chance event, splitting reality into new versions of itself. Cosmology offers its own clues. Some models of inflation, the rapid expansion after the Big Bang, predict not one universe, but endless bubbles of spacetime, each with its own laws of physics. In some, stars might never form. In others, life might be impossible. And in a rare few, maybe life thrives, but not as we know it. But here's the catch. By definition, other universes would be beyond our reach. No telescope can peer across the barrier. No experiment can touch them. That leaves us in a strange place. A theory that could be true, yet forever unprovable. Still, the multiverse is more than a thought experiment. It forces us to ask, if reality is infinite, then what does real even mean? And that question leads us directly into another shadowy frontier, the invisible matter and energy that dominate this universe. Chapter 11, Dark Matter, Dark Energy. Look up at the night sky and you might think you're seeing the universe in its entirety. Stars, galaxies, nebulae glowing across the void. But here's the unsettling truth. Everything we see accounts for less than 5% of what's really out there. The rest? A ghostly substance and an even stranger force we call dark matter and dark energy. Dark matter reveals itself only through gravity. Galaxies spin so fast that, by all rights, they should fly apart. The only explanation is that some invisible mass, far more abundant than stars, holds them together. Yet no one has ever seen or directly detected a single particle of it. It's like chasing a shadow that leaves fingerprints but never shows its face. Then comes dark energy, the name we give to whatever's causing the universe to expand faster and faster. It's not just stretching space. It's accelerating it, as though some hidden force is pushing the cosmos outward. But what is it? A property of space itself? A field we don't yet understand? Or something beyond physics entirely? Together, dark matter and dark energy make up about 95% of the universe. Which means that everything we've ever studied, everything we think we know, is only a tiny fraction of the story. And when it comes to the darkest mysteries of space, nothing embodies that paradox better than black holes. Chapter 12. Black holes, portals or graves. Few cosmic objects capture our imagination like black holes. They are the universe's ultimate paradox. Places where gravity is so intense that nothing, not even light, can escape. In a sense, they're both invisible and unmistakable, swallowing everything that dares to cross their threshold. Black holes begin their lives as the corpses of massive stars. When these giants collapse under their own weight, their cores compress into an infinitesimal point, a singularity. Around that singularity lies the event horizon, the boundary of no return. Cross it and every known law of physics breaks down. But here's the haunting part. What actually happens inside? Some scientists suggest black holes are cosmic graves, crushing matter into oblivion. Others propose they could be gateways, linking our universe to another through wormholes. The mathematics doesn't forbid it, but the reality remains cloaked behind the event horizon. Even information seems to vanish inside, sparking the information paradox. A debate that pits two of physics' greatest pillars, quantum mechanics and relativity, against each other. Both can't be right, yet neither can be dismissed. Black holes remind us that the universe doesn't just hide answers, it sometimes actively defies them. And that raises an even more unsettling possibility. Maybe our reality itself is not what it seems. Which leads us to a provocative idea. What if we're not living in a universe at all, but in a simulation? Chapter 13, The Simulation Hypothesis. What if everything you see, touch, and remember is code? Not metaphorically, literally lines of computation rendering your experience like a game. It sounds like science fiction, but the simulation hypothesis has quietly moved from dinner party speculation into serious philosophical and scientific conversation. Why? Because some of the deepest puzzles in physics and information theory make the idea not just imaginable but oddly plausible. Think about it this way. Progress in computing is relentless. We already build virtual worlds with millions of interacting elements. If a civilization grows far more powerful than ours, why wouldn't it run simulations of its ancestors? Detailed, faithful, and numerous. If simulated minds could exist, the logic goes, there might be vastly more simulated realities than base realities. Statistically, you might be more likely to be simulated than original. Then there are odd patterns in nature that look suspiciously like optimization, constants that seem finely tuned for life, or physical limits that resemble engineered constraints. Could those be signatures of someone else's design choices? Or are we just projecting human logic onto a universe that simply is? Of course, the hypothesis raises brutal questions. If we are simulated, who wrote the code? What are their motives? And crucially, can we ever test this? Some proposed experiments aim to find computational glitches or limits, but none so far offer a clean answer. It's the kind of idea that flips your sense of reality inside out, then leaves you staring at the pieces. So, comforting illusion, scientific possibility, or a philosophical trap? The simulation idea forces us to ask what real even means, and that question pushes us straight into the mathematical abyss. Chapter 14, The Problem of Infinity. Infinity seems simple at first. It's just forever, right? But the deeper you look, the stranger and more dangerous it becomes. In mathematics, infinity isn't a number you can count to. It's a concept, a horizon you can approach but never reach. And yet, infinity shows up everywhere, in equations, in cosmology, in the very structure of space and time. That should make it comforting. Instead, it makes it terrifying. Take the universe itself. Is it infinite in size? If so, that means somewhere out there, past unimaginable distances, another version of you exists, making the same choices, speaking the same words. Push further, and there could be infinite copies of every possible variation of you. Suddenly, infinity doesn't feel elegant, it feels overwhelming. Even in physics, infinity causes chaos. At the center of black holes, equations explode into singularities, where density is infinite and the math simply breaks. It's as if nature itself refuses to play by its own rules once infinity enters the scene. And yet, without infinity, some of our greatest theories collapse. We can't fully model the universe without invoking it. So is infinity a real feature of reality, or just a symbol of the limits of human thought? One thing's certain. If infinity haunts mathematics, then the gaps in physics become even more glaring. Because beyond infinity lies something equally frustrating: the missing pieces of our most trusted theories. Chapter 15, The Missing Pieces of Physics. On paper, modern physics looks unstoppable. We have Einstein's relativity to explain the vast, cosmic scale. We have quantum mechanics to describe the tiny, subatomic world. Both theories are astonishingly accurate, tested again and again, never failing. And yet, they don't fit together. Like two puzzle pieces from different sets, they refuse to lock. Try to combine them, say, to describe what happens inside a black hole or at the moment of the Big Bang, and the math collapses into nonsense. This is the infamous rift between general relativity and quantum mechanics. Physicists have hunted for a theory of everything that unites them, with candidates like string theory or loop quantum gravity. But so far, none have delivered testable proof. Then there's the standard model of particle physics, an elegant framework that predicts the behavior of fundamental particles. It works beautifully, except it doesn't include gravity. It also can't explain dark matter, dark energy, or why the universe even has more matter than antimatter. These gaps aren't small details, they're enormous, glaring holes. It's like building a magnificent bridge that spans miles, only to realize there's no foundation beneath it. So where does that leave us? With a universe that appears to work, yet is stitched together with contradictions. And if our physics is incomplete, perhaps it's because our very senses blind us to a deeper layer of reality. Chapter 16, The Limits of Human Senses. For all our ambition, we're still animals, creatures with fragile bodies and narrow senses. And that limitation might be the biggest barrier between us and the truth. Think about sight. We pride ourselves on what we can see, yet our eyes capture only a tiny sliver of the electromagnetic spectrum. We're blind to radio waves, microwaves, ultraviolet, and X-rays unless we build machines to extend our vision. To a bee, the world is painted in ultraviolet patterns. To a bat, it's mapped in echoes. To us, just the slice our biology allows. The same is true for sound, smell, and touch. We sense enough to survive, but nowhere near enough to perceive reality in full. Even with technology, we're still translating those hidden worlds back into the narrow channels our brains can handle. So here's the unsettling thought. What if the deepest mysteries of the universe don't look strange to us because they are strange, but because we simply lack the tools to perceive them as they are? It would be like asking a goldfish to imagine the internet. Science pushes those limits outward, but ultimately, we're decoding the cosmos through human senses, human logic, human imagination. Maybe that's why so many mysteries bleed into something stranger, where psychology, culture, and the unexplained blur together. Which brings us to a different frontier, the realm of the paranormal. Chapter 17, Paranormal or Psychological. For as long as we've told stories, humans have spoken of ghosts, visions, and forces beyond the natural world. Entire cultures were built on myths of spirits, gods, and unseen powers. And even today, in an age of satellites and quantum computers, millions still report strange experiences. So what's really going on? Are these glimpses into something science has yet to uncover, or are they products of the mind? Take ghosts, for example. Many encounters happen in old houses late at night, often when people are tired. Neurology shows that the brain under stress or sleep deprivation can create vivid hallucinations. Infrasound, low-frequency vibrations below human hearing, can even trigger feelings of unease or shadowy visions. A haunted house might simply be a noisy one. UFO sightings, too, often turn out to be aircraft, atmospheric phenomena, or optical illusions. And yet, not all cases fit neatly into rational boxes. Some remain stubbornly unexplained. Here lies the tension. The line between external mystery and internal perception is thin. Our brains are wired to see patterns, even when none exist. That instinct kept our ancestors alive, but it also means we sometimes invent meaning where there is only noise. Still, the persistence of these stories says something powerful. Whether real or imagined, the paranormal taps into the same well as science itself. The yearning to believe there is more than meets the eye. And that same yearning echoes through history's greatest unsolved mysteries. Chapter 18, History's Unsolved Cases. Science loves to rewrite history with answers. We've decoded ancient scripts, mapped forgotten cities, even extracted DNA from long-dead kings. But some mysteries remain stubborn, as if daring us to solve them. Take the Voynich manuscript, a book filled with strange symbols, bizarre plants, and coded text written in a language no one has ever spoken. For over 500 years, scholars, cryptographers, even AI have tried to crack it. Yet it still defies translation. Is it a code? A hoax? Or knowledge from a worldview we no longer understand? Then there's the Great Pyramids. We know who built them and roughly when, but the how still sparks debate. The precision of the stonework, the astronomical alignments, the sheer scale of labor involved. Some argue we're still underestimating the genius of ancient engineers. Or consider the Antikythera mechanism, discovered in a shipwreck off Greece. Built over 2,000 years ago, it's essentially a mechanical computer capable of predicting eclipses and planetary motions. Its sophistication stunned historians, raising the question, how much ancient knowledge has been lost to time? These puzzles remind us that mystery isn't confined to the cosmos. It's woven into human history itself. And each unsolved case reflects something deeper. Not just what we don't know, but how belief, culture, and imagination shape what we're willing to accept. Which leads us to the next piece of the puzzle. The raw power of belief. Chapter 19, The Power of Belief. Belief is one of the most powerful forces humans wield. Not just culturally, but psychologically and even physically. It shapes how we interpret mysteries, and sometimes, it shapes the mystery itself. Consider the placebo effect. Give someone a sugar pill and tell them it's medicine, and their body can actually respond as if it were real treatment. Pain eases. Symptoms fade. The mind's conviction can spark measurable changes in the body. That's not superstition, that's biology responding to belief. On a larger scale, entire civilizations were built on shared beliefs. Ancient sailors navigated oceans guided by star myths. Nations have risen and fallen on prophecies, omens, and visions. Belief doesn't just explain reality, it constructs it. When people encounter the unexplained, belief often fills the gap science cannot. A strange light in the sky becomes a UFO for some, an angel for others, a classified aircraft for skeptics. The event is the same. Interpretation is dictated by worldview. And here's the paradox. Belief can blind us, but it can also drive discovery. Many of history's greatest scientists pursued knowledge because they believed the universe was ordered, knowable, and worth understanding. Without that conviction, progress might never have begun. But what happens when even scientists can't agree on what's real? That tension reveals something deeper. The mystery isn't just in the unknown. It's in the debates we still can't settle. Chapter 20: When Scientists Disagree. Science often presents itself as a steady march toward truth. Hypotheses tested, data gathered, theories refined. But the reality is far messier. Even the most brilliant scientists often stand on opposite sides of the same mystery. Take quantum mechanics. Niels Bohr insisted particles don't have definite properties until they're observed. The Copenhagen interpretation. Einstein hated that idea, famously saying, "God does not play dice with the universe." To him, the quantum world had to be governed by hidden rules we just hadn't discovered yet. Nearly a century later, the argument still rages. Or consider the origin of the universe. Some physicists argue for a singular Big Bang out of nothing. Others propose cyclic models, where universes expand and collapse endlessly. Both camps wield mathematics and evidence, but neither has the final word. Even in biology, debates persist. Is consciousness purely an emergent property of neurons? Or does it point to something fundamental in the fabric of reality? Neuroscientists, philosophers, and physicists all stake claims, but no one fully agrees. These disagreements aren't signs of weakness, they're signs of the edges of knowledge. Science thrives on conflict, on the friction between ideas. But for the rest of us, they're reminders that even the experts don't have all the answers. Which raises another question. If humans can't settle the mysteries alone, could technology one day do it for us? Chapter 21: The Role of Technology. Throughout history, every leap in understanding has followed a leap in tools. The telescope revealed galaxies. The microscope unveiled entire worlds in a drop of water. The particle accelerator uncovered the hidden zoo of subatomic particles. So it's natural to wonder, could technology one day solve the mysteries that baffle us now? Artificial intelligence, for example, can sift through mountains of data faster than any human. It spots patterns we'd miss, generates models, even proposes hypotheses. Some scientists imagine AI discovering laws of nature hidden beyond our cognitive reach, like an alien mathematician working tirelessly at our side. Quantum computers, still in their infancy, could simulate realities so complex they're impossible for classical machines. They might finally let us peer into the paradoxes of black holes or the tangled webs of quantum entanglement. And yet, there's a catch. Technology amplifies our reach, but it doesn't change the foundation. We still interpret results through human logic, human senses, human bias. A machine might spit out the answer, but will we even recognize it as truth? It's possible that technology will hand us the keys, but the door it opens could be so alien, so beyond intuition, that stepping through feels impossible. Which brings us to a deeper crossroad, the place where science meets its oldest companion, philosophy. Chapter 22: Philosophy Meets Science. Long before laboratories and particle accelerators, philosophy was humanity's first science. Thinkers like Plato, Aristotle, and Descartes asked the same kinds of questions we still wrestle with today. What is reality? What can we know? What does it mean to exist? Modern science often prides itself on leaving philosophy behind, relying on data instead of speculation. But at the edges of knowledge, the two inevitably collide. When physics asks what time really is, that's not just a scientific problem, it's a philosophical one. When neuroscience asks whether free will exists, it's echoing debates as old as civilization. Even the act of doing science rests on philosophical assumptions. that the universe is consistent, that our observations reflect something real, that truth is discoverable at all. Strip those away, and the entire enterprise collapses. Philosophy also provides a lens for questions science can't test directly. Is consciousness fundamental or emergent? Are other universes real, if we can never observe them? These aren't just technical puzzles. They're questions about meaning, truth, and existence itself. And here's the irony. Sometimes philosophy dares to ask the questions science avoids, keeping the flame alive until tools catch up. In that way, philosophy isn't a rival to science. It's its shadow, its mirror, and sometimes its guide. But whether in the lab or in the library, one truth remains. Mystery isn't a flaw to erase. It might be the very fuel of progress. Chapter 23: Why Mystery Matters. At first glance, mystery feels like a problem, an obstacle to be eliminated. After all, science thrives on answers, not question marks. But look closer, and you'll see the opposite is true. Mystery is the engine that drives discovery. Without the riddle of disease, we wouldn't have medicine. Without the puzzle of the stars, we wouldn't have astronomy. Every breakthrough, every revolution, begins not with certainty but with confusion. It starts with someone daring to ask, why doesn't this make sense? Mystery also humbles us. It reminds us that, no matter how advanced we become, there are limits. That humility keeps us curious, open to new ideas, willing to challenge what we think we know. Without it, progress would stagnate. And there's another layer: mystery fuels imagination. The gaps in knowledge become canvases for stories, myths, even art. From cave paintings to space operas, we fill the unknown with wonder. In doing so, we push boundaries both scientifically and creatively. So maybe the goal isn't to banish mystery, but to embrace it, accepting that some questions may never have neat answers, yet still chasing them anyway. Because the pursuit itself transforms us. But what if some mysteries aren't just unanswered, but unanswerable? What if the darkness isn't temporary at all, but permanent? Chapter 24: The Darkest Possibility. What if the universe isn't waiting to be fully explained? What if some questions are destined to remain forever unanswered? It's a possibility that unsettles even the most hardened scientists. Consider consciousness. Decades of research have given us brain scans, neural maps, and computational models. Yet the essence of awareness still slips through our fingers. Or take the origin of the universe. We can rewind the cosmic clock to fractions of a second after the Big Bang, but the very moment of creation remains hidden behind a veil no equation can pierce. Maybe these gaps exist not because we're missing data, but because our minds are simply incapable of grasping the answers. Just as a dog can't understand algebra, perhaps humans can't comprehend certain truths about reality. Our brains evolved to survive on Earth, not to decode the ultimate nature of existence. It's a humbling, even frightening thought, that some mysteries are not stepping stones to knowledge, but walls we can never climb. And yet, within that darkness lies a strange kind of beauty, because the unsolvable doesn't diminish us, it defines us, keeps us questioning, imagining, reaching further than we otherwise might. Which brings us, finally, to the closing circle of this journey. Embracing the eternal unknown, and what it means for us to live inside it. Chapter 25: Closing the Circle. We began with a question. What is the darkest mystery science can't solve? Along the way, we journeyed through black holes, dark matter, consciousness, time, ancient enigmas, and the very limits of human thought. Each chapter brought us closer to a truth that is both unsettling and liberating. Mystery is not an enemy of science, it's its heartbeat. The universe may never surrender all its secrets. Some questions may remain beyond the reach of experiments, equations, or even imagination. But maybe that's the point. Maybe the beauty of existence lies not in final answers, but in the endless pursuit. Think of it. Every unsolved riddle keeps us alive with wonder. Every unexplained phenomenon invites the next generation to try again. Mystery isn't a void, it's a horizon. And horizons, by definition, are meant to be chased. So when you look up at the night sky, or wonder about the strange flickers of your own consciousness, remember, It's okay not to know. It's okay for the universe to remain a little wild, a little untamed. Because in that uncertainty, we find awe. And maybe, just maybe, the darkest mystery isn't something to be solved at all. It's something to be lived with. Something that reminds us we are small, curious, and beautifully unfinished.